Welcome back to Mr. Silver's Math. Today we're going to focus on solving systems of linear equations by elimination. So the past 2 days we've been solving systems of equations. The first was by graphing, and then the second was by substitution. So by now this is the third time that you have seen this page, and it's just giving all the different examples of what we might see when we solve a systems of equations. So we could have a system that has one solution or no solution or many solutions. Here's what they look like graphically. Two lines that intersect would be for one solution. No solution would be parallel lines, and many solutions would be the same line. Now, since we're solving by elimination, we are focusing on this part down here by how they look in an equation after you solve. Since that's what we're doing, we're going to solve using elimination. So if after we solve elimination we get x equals -1 or y equals 10, we know that we have two lines that intersect, and our answer would be at this ordered pair, -1, 10. If after we solve we get something that says 3 equals 0 or something that's not a true statement, we know that we have no solution, meaning we have two lines that are parallel. There's no answer, there's no x or y value that will make both equations true. And then the last one, after we solve an equation, if we get x equals x or 7 equals 7 or any other true or true statement, we know that we have the same line. So we're going to have many solutions. And we talked about this in the last video. Many solutions is what I'm going to ask my students to state, but you may have other students, other friends that tell you that's not possible. Their teacher wants them to list infinitely many solutions or infinite solutions. They mean the same thing. Okay? But I'm just focusing and saying many solutions if we have a true statement. So solving by elimination. So let's think about, what does elimination even mean? It means to get rid of something. I want to eliminate the pest problem, right? Because you have pests in your house. I want to eliminate the spiders in my house. I want to eliminate the rabbits from getting in my garden. And you're trying to get rid of something. So here's the first example. It's all worked out, and I just have a few extra notes as we go through it. So it says you're going to add going down. So right now that doesn't make a whole lot of sense. But when we do elimination, we want to add going down. We're going to add vertically. So 3x plus 3x is 6x. 4y plus -4y is 0. I eliminated the y's, and that's what I wanted. I wanted to eliminate one of the variables, whether it's x or y, it doesn't matter. In this case, the y's eliminated, so that's why I don't have y's in this new equation. And then I keep going. 16 plus 8 is going to give me 24. And then I solve. I get x equals 4. Now from here, the second part of this should look familiar because we did this with substitution. So x equals 4, I take that and I substitute that back into either equation to solve for the other variable. So in this case, I plugged it into the top equation. 3 times 4, because remember, originally it said 3x. I'm replacing x, I'm substituting x with 4. So I'm doing 3 times 4 plus 4y equals 16. And then I'm just solving my equation like I have in the past. 3 times 4 is 12. Subtract 12 from both sides and divide by 4. So my solution is x equals 4, y equals 1. So that means I have an ordered pair of 4, 1. If I were to graph both lines, they would intersect at 4, 1. Or if I were to take x equals 4 and y equals 1, substitute it into both equations, it would make them true. So there's an example already worked out, but what if it's not already worked out? And that's where we get into this one. Here's some steps for success. Right? So number 1 says align like terms vertically. So what I mean by that is these are my x's. I'm going to line those up vertically. I have some sort of operation. I have my y terms. I have my equal sign, and I have my constant. That's what I mean by aligning my like terms vertically. So going up and down, they should be the same like terms. Once that's done, I need to eliminate one of the variables with addition or subtraction. Now, for purposes of this class, those are the only two options you have. You're either going to add going down or you're going to subtract going down, or the additive inverse if you want to think of it that way. So if you are in a different math class than Mr. Slover's class, you may have to do something else with number 2. You may have to multiply one or both of the equations to eliminate your variables. But for purposes of my class, we are just going to add or subtract. I'm always going to suggest adding first because adding is way easier than subtracting. So we look at this problem. Step 1 is done. So now we're going to try and add. And I have this note over here that we're going to add going down. I'm just reminding us that's what we're doing. So negative 6x plus 6x. All right, so in your calculator, you can do negative 6 plus 6 because you can't put the x in your calculators. So negative 6 plus 6 is 0. Well, that x then is gone, 0x, negative 6x plus x. That's gone, no more x's. I eliminated the variable. That's what I wanted. Well, I keep going. 5y plus 4y gives me 9, 9y. 1 plus negative 10 is negative 9. And then I solve for y. Divide both sides by 9, y is negative 1. I am choosing to substitute in y is negative 1 into the bottom equation. It does not matter which, I just chose the bottom one. So 6x plus 4 times negative 1, I'm showing you I'm plugging it in, equals negative 10. And then I'm just solving from there. 4 times negative 1 is negative 4. I add 4 to both sides. Make sure you bring that negative down with you. So negative 10 is up there. Down here it's negative 10 as well. So negative 10 plus 4 gives me negative 6. Divide both sides by 6, and I get x is negative 1. So my solution is x and then y. So negative 1, and that should say negative 1. I just missed my negative. So once again, this should be negative 1, negative 1. Letter B. So I still followed my steps. Align like terms vertically. X's, operation, y's, equal sign, constants. Eliminate using addition or subtraction. I'm always going to suggest addition. So if I were to add going down, this was not here. That's not saying negative 10x. That is me adding going down or subtracting. It originally had a 10x and a 10x. So if I did 10x plus 10x, that would not eliminate. If I did 2y plus negative 7y, that would not eliminate. So that's why I can't use addition. I have to try subtraction. And just like before, when I added going down, I'm going to subtract going down. So now that everything's lined up vertically, because step 1 is done, I can go ahead and do that vertical subtraction. So this is saying 10x minus 10x. Well, 10x minus 10x is 0x, right? The x's are gone. 10 minus 10. I have 10 of something. I took 10 away of that same something. Nothing is left. Here's the tricky part. This is saying, so here I did 10x minus 10x. But I need to keep doing that subtraction all the way throughout the problem. So this is really saying 2y minus negative 7y. And that's what I wrote over here in red. 2y minus negative 7y. That gives me 9y. It's the same thing over here. It's not 18 minus 18. It's 18 minus negative 18. 18 minus negative 18 gives me 36. So subtraction is a little bit more tricky than my addition. But I believe that you can go ahead and still get the correct answer. Showing your work is totally okay. There's nothing wrong with that. So now I have 9y equals 36. I divide both sides by 9, and I get y is 4. And I'm back to our good old substitution, where I substitute, in this case, y is 4 into either equation and solve. I chose the top one, so 10x plus 2 times 4, because I substituted the y for a 4, equals 18. 2 times 4 is 8. Subtract 8 from both sides. 10x equals 10, and then divide by 10. And I write my solution. The last one I want to talk about is example 3. So step 1 says align like terms vertically. Well, if I look what's printed, what I gave you, I have a y and an x. Those are not lined up correctly. I want the same variable, just like I did up here, like terms, x and x, and then operation y and y. That's not the case here, so I need to switch it. So I'm going to switch my terms around. I'm switching my negative 8y and my negative 4x. I can do that, right? Your commutative property of, your associative property of commutative property of association. Sorry, fumbling on my words here. Which means we can just switch these around. 3 plus 4 is the same as 4 plus 3. Right? Very basic example to think of. So I can do the same thing down here. I can switch my negative 8y and my minus 4x around. Right? This equation stayed the same, so I just rewrote it. And then it's the bottom one that I changed. So now I have my x term up front because I want to line up my like terms vertically. So I switched and I have a negative 4x up front, and then I have the minus 8y in the middle now. And I still have the equals 24. So I'm going to always suggest try the adding going down first because it's easier. So 4x plus negative 4x is 0. That's gone. One of my variables eliminated, which is what I want using elimination. 8y plus negative 8y is also 0. So now I have both my variables eliminated. I'm left with nothing over there. So I'm left with 0. And then I keep going. Negative 24 plus 24. Well, that also gives me 0. So I'm left with 0 equals 0. Now, is that a true statement? Yeah, 0 does equal 0. So because that is a true statement, I'm going to write many solutions, which means any x or y value that I can come up with, I can plug in and we'll make both equations true. So when you're solving for elimination or you're solving a systems by elimination, make sure you're using these steps for success. It will help you immensely. If you have any questions, make sure you reach out and let me know.